Hi there, welcome back to my channel. So in this video, I'm going to solve a problem which is a Jacobi method with you. So it said given the system of equations. So this is a system of equations here. It said find a solution given that our initial guess is 101. So we have to use the Jacobi method, which is the iterative method. Okay. So if this is the first time you've been on this channel, kindly subscribe and please watch this video to the end. So let's see. In the previous lesson, I indicated the algorithm for solving Jacobi's method. So we are just going to upgrade on that. Kindly visit the previous lesson if this is the first time you've been on this channel as well. So I have 12x1 plus 3x2 minus 5x3 is equal to 1. x1 plus 5x2 plus 3x3 equals 28. 3x1 plus 7x2 plus 13x3 is equal to 76. So to use the Jacobi's method, I said you are to make what? The first unknown here, x1 the variable in the first equation, x2 the variable in the second equation, and x3 the variable in the third equation. But in all cases, you realize that the coefficient of what? X1 happens to have the highest magnitude in terms of all the three. The coefficient of x2 in the second equation will have the highest magnitude in terms of all the three. And finally, x3 in the third equation will have the highest than all the three. This is what we call diagonally dominant. Okay, diagonally dominant. Okay, so for the purpose of convergence, if you want to find the solutions using the Jacobi's method, then you should have a matrix which is diagonally dominant. That's the condition. You should have a matrix which is diagonally dominant. So the diagonally dominance means that when I take absolute of what? Of my when I take absolute of my what? Entries. So if I represent this as a matrix, you realize that I'll have something like this. 12, 3, neg 5. I'll have 1, 5, 3. I'll have 3, 7, 13, right? So if you want to show if this is diagonally dominant, when I take the magnitude, that's the absolute of each of the entries, you realize that the elements on the principal diagonals, right, happens to be the what? The largest in magnitude in each row. In each row. So in the first row, 12 is bigger than 3 and bigger than what? 5. In the second row, 5 is bigger than what? 3. So it's actually the absolute of what? Let's say 12 should be what? Greater than or equal to the sum of the absolute of 3 plus the sum of the absolute of what? 5. Negative 5, right? So the elements on the principal diagonal should always be greater than or equal to the sum of the magnitude of what? The other in any of the rows for this to be what? Diagonally dominant. So this was just an illustration to show you the condition for what? Convergence. So our matrix has already been ordered for us. So we are just to make our x1, x2, x3 the subjects. Okay. So I'll treat convergence and diagonal dominance in our later tutorials. So don't forget to subscribe so that you get updated when I post new videos. So for this equation, to apply Jacobi's method, simply you make x1 the subject in the first equation. So our x1 will be equal to, you have 1 here, right? 1 minus what? 3x2. I'll send this there, so it will be plus 5x3, right? All over the coefficient of x1, which is 12. My x2 becomes also 28 minus what? X3, so 3x3, then I have x1 here minus x1 all over the coefficient of x2, which is what? 5. Then x3 is equal to 76 minus 3x1 minus 7x2 all over the coefficient of x3, which is 13. So once you've made each of the unknown the subjects like this, the next thing to do is to perform your iterations. So the question didn't state the number of iterations, but you're going to do 3 iterations. So for examination purposes, the number of iterations to be stated. So here, let's do 3 iterations and see. So for the first iteration, what you do is you have to find new values for the unknown. So my x1 will attain a new value simply by substituting the initial guess into it. So x1 is simply equal to 1 minus 3. My x2 is 0. You just simply put 0 here. Plus 5. The x0 is 1. All over what? 12, right? So this becomes what? My x1. So this becomes my x1, and this is giving me what? 0.5, right? Because this should be 0, you'll be getting what? 1 plus 5, which is 6. 6 on 12 is what? 0.5. Now when I come to the x2, for the x2, I'll have 28 minus 3, my x3 is 1, minus my x1 is also 1, all over 5. So 28 minus 4, 24 on 5, and that will give us 4.8. 4.8. Then my x3 will be equal to 76 minus 3 open bracket x1, right? X1 here is what? Is 1. Okay, so you just write 1. Then minus 7, x2 is 0, all over 13. And this should give us 5.6154 if correctly punched on the calculator. So after the first iteration, the set of values you are getting is what? X1, x2, x3 is equal to x1 is what? 0.5, x2 4.8, then x3 5.6154, right? You close bracket. So this is for our first iteration. So we have got the values for our first iteration. For the second iteration, it's nothing except to put in our new iterant values into the unknowns back again. So for our x1, when I come, I'll have 1 minus what? 3x squared. Sorry, 1 minus what? 3x2, right? So let me clean my entries, then find the new x1 value using the first iterant value. Okay, using the first iterant value. So for x1, I'll have x1 to be 1 minus 3 open brackets, x2 here is what? 4.8, right? 4.8 plus 5 multiplying x3 here is what? 5.6154, all over what? 12. And this gives us what? 14.667, right? X1 gives us 14.667. 14.667. So let me write second iteration. Second iteration. So for second iteration, I'll have x1, x2, x3 to be equal to. Now I'm having from this equation, I'm going to get x1 to be what? 14.677. Okay. Now what is x2? Let me clean the x2 entries and replace it with the current one that we have, right? Yep. So my new x2 is 28 minus 3. My x3 is what? 5.6154 minus my x1 0.5. Okay. All over the expression 5. And what am I getting for h2? My h2 is simply giving us 2.13076. So 2.13076. Okay. Then finally our x3. So I'll clean the x3 here. Then I'll clean this. So my x3 is simply equal to, I have it here. So 76 minus 3. Then the x1 here becomes 0.5 minus 7 multiplying x2, which is 4.8. Close brackets all over the expression of 13. And what am I getting for this? 3 points. So this is giving me 3.14615. Okay, so you simply write 3.14615. So now I have values for my second iteration. Then finally we write our third iteration. our third iteration. So you realize that this is a simple process. It's just a substitution, then you find new values, then you will resubstitute. That's all. So with our third iteration, the input will be what? The input of the second iteration. So I'll also clean each. So I'll find the value for the new x1. Okay, values for the new x1 here, like that. So for x1, I'm going to get 1 minus 3. My x2 now is 2.13076 plus 5 multiplying my x3 result 3.14615. Okay, all over 12. And what am I getting for this? I'm getting okay, okay. So you do same for the x2. So we simply punch this one into the calculator. So we are having 1 minus 3 multiplying 2.13076 minus 7 times open brackets 4.8 all over 13. So we're getting our third iteration. So I'll have my x1 to be negative 2.999. Okay, then now let's come to the third iteration for the x2. For the x2, the third iteration is simply values into the original equation. So 3.1414615 minus our x1 14.677 all over 5, right? So we simply punch this into the calculator. 28 minus 3 multiplying 3.14615 minus 14.677 all over 5. And this is giving me 0.77691. Okay, so 0.77691. So it's advisable to leave your decimal places to a consistent number of places, and it's advisable to make it 4. Okay, always do it 4. So with 0.5 you can make it 0.5000, 4.800 to ensure consistency of results. Okay, so now let's finally come to the x3 here, x3 here, x3. So with the x3, I simply have 76 minus 3 multiplying the x1, which is what? My new x1 is 14.677 minus 7, x2 is 2.13076 all over the expression 13. You punch this one into the calculator, which is 76 minus 3 multiplying 14.677 minus 7, 2.13076 all out of 13. So 1.3118, right? So I'll have 1.3118. So this becomes the end of our iteration process. Okay, I have the first iteration, I have the second, and I have the third iteration. Now let me introduce you to a concept called the absolute relative error. Absolute relative error. Okay, so now because we are iterating or we are guessing the value, we didn't go ahead to solve for the system, but we are trying to assume that the values are this and we are iterating. So meaning that at each iteration level, we are going to have a deviation of our solution from the actual answer. Okay, and also because it's relative, it's the error is relative to our first iteration provided we are in the second iteration. If we are in the third iteration, our relative error will be with respect to what our second iteration. So we don't know what the actual answer is. But with respect to our method, you find the approximate absolute relative error. So how do you do that? The the formula is given as the current value, right? The You just write the current value minus the, so let's say we have what we call s to the power what, sk, right? Then you have, let's say, sk plus 1. Okay, so for the different iteration, this one is your original, sk plus 1 becomes your what, iterant value. So we simply have s to the power k plus 1, right, minus the original all over s to the power k plus 1 times 100%. This gives us our absolute error. Okay, but we take absolute of this because you are subtracting, it's possible to get minus. We have to eliminate every minus. You're not interested in the minus sign, right? So this minus this all times 100%. So with respect to our iteration, for the first iteration, okay, we can find the approximate error for each. So let's say for the first one, x1 is 0.5, right? So I'll have my approximate error to be 0.5 minus the initial guess. So the initial guess, x was what, x1 was what, initial guess I had x1 to be 1 from the question, 1. So simply do 0.5 minus 1 all over 0.5 times what, 100%, right? So this gives us our percentage error, and when I punch this on the calculator, I'll be getting 0.5 minus 1 over 0.5 times 100. So the answer is giving us 100% because it's absolute of this. Okay, so answer is 100%. So meaning you are having 100% error. The question will ask you to find the absolute error if it wants you to. Okay, so by the way, thank you for being with me in this video. This is the end of this section. Kindly subscribe to support, and please follow me as I post relevant videos on this channel.